Good morning, everyone. Welcome to today's presentation. I'm Dr. S.K. Singh, and I'm pleased to have the opportunity to talk with you about calibration of volumetric flasks. Today, we'll explore what calibration involves, why it's important, and how it's done to ensure accuracy in our measurements. I hope you find the session informative and engaging. Let's get started. Let's talk about why calibration of volumetric flasks is so important. First, calibrating them ensures the accuracy of the volumes we measure, which is crucial for reliable results. When our measurements are accurate, we reduce the chance of systematic errors that can skew our data. This is especially important when we need to meet strict standards like those set by USB, ISO, or ICH. Calibration also supports the traceability of our measurements, meaning we can trace back to recognized standards, adding confidence to our data. Additionally, regularly calibrating helps us minimize variability between batches, ensuring consistency across our analyses. Overall, calibration is a key step in maintaining precision, compliance, and trustworthiness in our laboratory work. Let's start with calibration. This is essentially the process of comparing our measurement device against a reference standard to ensure accuracy. Think of it as a way to verify that our tools are giving us correct readings. Next, we have tolerance. This refers to the permissible deviation from the nominal volume. In other words, how much variation we can allow before the measurement is considered out of acceptable bounds. It's important because it defines the acceptable accuracy range for our measurements. Now let's talk about meniscus. When you're measuring liquids in a container, you'll notice the liquid surface curves, and that's called the meniscus. For precise readings, we always take the measurement at the bottom of this curve, ensuring consistency and accuracy. Finally, traceability. This is about establishing a clear link between our measurements and national or international standards. It ensures that our measurements are reliable and can be compared across different laboratories or regions. All these concepts, calibration, tolerance, meniscus, and traceability, are fundamental to maintaining measurement quality and consistency. They form the backbone of accurate and trustworthy measurement practices in any scientific or industrial setting. Let's take a closer look at regulatory norms, which are essential standards that govern calibration processes. First, we have the United States Pharmacopoeia, or USB, which sets specific tolerances for volumetric glassware. These tolerances ensure that measurements are consistent and reliable across different labs and applications. Moving on, ISO 1042 is another important standard that specifies accuracy classes, namely Class A and Class B, to categorize the precision of volumetric equipment. This helps us understand the level of accuracy we can expect from different instruments. Lastly, the ICH Q2 R1 guideline focuses on validating analytical methods, ensuring that they are both precise and accurate. All these norms work together to uphold quality and consistency in calibration, which is at the core of our overall theme, maintaining high standards in laboratory practices. Let's take a closer look at the calibration principle, specifically the mass-volume relationship. This is a fundamental concept in volumetric measurements. Essentially, we use the gravimetric method for calibration, which involves measuring the mass of water and then converting that into volume. Since water density varies with temperature, we base our calibration on the known density of water at a specific temperature to ensure accuracy. By measuring the mass of water in a flask, we can accurately determine its volume, which is crucial for precise volumetric work. Now, moving on to the classes of volumetric flasks, these come in different types, each designed for specific levels of accuracy and precision. Understanding these classes helps us choose the right flask for our particular needs, whether it's for routine measurements or highly precise laboratory work. Overall, mastering these principles ensures that our measurements are reliable and consistent, which is the backbone of good laboratory practice. Let's take a closer look at the calibration formula. This formula is essential because it helps us translate our raw measurements into accurate, meaningful data. Essentially, it serves as the mathematical bridge between what we observe and what we want to understand. When we talk about calibration, we're aiming to correct for any systematic errors in our measurements, ensuring consistency and reliability. The formula itself typically involves factors like the known reference standards, the raw readings, and sometimes correction coefficients. By applying this formula, we can fine-tune our instruments and improve the overall accuracy of our data collection process. Remember, calibration is a critical step in maintaining the integrity of our results, especially when precision is key. So, understanding this formula helps us ensure that our measurements truly reflect the real-world values we're investigating. All right, let's walk through the setup and procedure for this experiment. First, you'll need some equipment, an analytical balance accurate to plus or minus 0, 1 milligrams, a thermometer to measure temperature, deionized water to ensure purity, a volumetric flask along with a funnel for pouring, and a timer to keep track of any timing requirements. When it comes to the procedure itself, the first step is to equilibrate both the water and the flask to around 20 degrees Celsius, give or take a degree. This is crucial because temperature affects volume and density, so we want everything at a consistent temperature. Next, zero the balance with a beaker. This ensures that any weight we record later is just the weight of the water, not the beaker itself. Then, carefully fill the flask up to the calibration mark, making sure to do this precisely. Once filled, record the mass of the water in the flask. This process allows us to determine the exact amount of water in the flask, which is fundamental for accurate measurements. Remember, maintaining proper temperature and precise measurements are key to ensuring the accuracy and reliability of your results throughout this experiment. Let's take a look at this example calculation to see how these concepts come together in practice. First, we start by identifying the key variables involved. Then, we apply the specific formulas we've discussed earlier to these variables. As we go through each step, notice how the numbers chain and what that tells us about the process. This example helps solidify our understanding by putting theory into real-world context. It's a practical way to see how these calculations are performed and why they matter for the overall project. By walking through this, you'll be better equipped to handle similar calculations on your own. Factors affecting calibration are crucial to understand because they can significantly influence the accuracy of our measurements. Let's talk about some common sources of error that can creep into the process. First, temperature variation is a big one. Changes in temperature can affect the volume of liquids and the calibration of instruments, so it's important to perform calibrations in a controlled environment. Next, reading meniscus incorrectly is a frequent mistake. When measuring liquids in a graduated cylinder or similar device, always read at eye level and from the bottom of the meniscus to ensure accuracy. Evaporation can also cause errors, especially during long measurement processes. If the liquid evaporates, the volume decreases, leading to inaccurate readings. Covering containers can help minimize this issue. Contamination plays a role too. If the container or liquid becomes contaminated, it can alter the properties of the sample and affect calibration results. Always ensure your equipment is clean and pure. Air bubbles are another source of error. If air gets trapped in the measurement device or on the sample, it can displace liquid and give false readings. Carefully debubble your samples for precise measurements. Finally, human error is always a factor. This includes misreading measurements, improper handling, or inconsistent procedures. Attention to detail and proper training are key to reducing these errors. All of these factors are interconnected with the overall theme of calibration accuracy, and being mindful of them helps ensure our measurements are as reliable as possible. Now, let's talk about uncertainty and precision. When we perform measurements, there's always some level of uncertainty involved. To handle this, we calculate the overall uncertainty by combining the errors from both our instruments and procedures. This way, we get a more realistic picture of how precise our measurement really is. We often use what's called expanded uncertainty, with a coverage factor of k equals 2, which gives us about a 95% confidence level. This means we're pretty sure that our true value falls within this range. For example, if our balance has an uncertainty of plus or minus 0.2 milligrams, and the water density has an uncertainty of plus or minus 0.005 grams per milliliter, we combine these uncertainties to determine the final overall uncertainty. This process is crucial because it ensures we understand and communicate the reliability of our measurements, which ties back to the overall goal of achieving accurate and trustworthy results. Let's talk about what to do when we encounter out-of-tolerance results. First, it's crucial to document the deviation thoroughly. This helps us keep track of what happened and provides a record for future analysis. Next, we need to investigate the root cause of the issue. Understanding why the deviation occurred is key to preventing it from happening again. Recalibrating the equipment might be necessary to ensure accuracy moving forward. If we identify any glassware that is out of tolerance, we should remove it from service immediately to avoid contaminating other samples or experiments. Lastly, reviewing handling procedures is important. This ensures everyone is following best practices and helps us improve our processes overall. By taking these actions, we maintain the integrity of our results and uphold the quality standards we're committed to. Let's talk about documentation and traceability, which are crucial for maintaining quality and accountability. When recording our data, we need to include several key pieces of information. First, the operator's name, so we know who performed the task. Next, the date and time. This helps us track when each step was completed. Environmental conditions are also important, as they can impact the measurements. We should record the status of the balance calibration to ensure our equipment is accurate. Water temperature is another vital factor, especially if it influences the results. The measured mass or volume must be carefully documented to maintain data integrity. Finally, the final approval signifies that the record has been reviewed and authorized. All these elements work together to create a complete, traceable record of the process, supporting both quality control and compliance. They ensure that each step can be verified and any issues traced back to their source, which is fundamental in maintaining our standards and continuous improvement. Let's talk about some best practices to ensure accuracy and consistency in our procedures. First, always calibrate volumetric flasks according to USB or ISO procedures. This step is crucial because it guarantees that our measurements are reliable and traceable to recognized standards. Next, I recommend using the gravimetric method whenever possible. It tends to be more precise and helps verify the accuracy of our measurements. Documentation is another key point. Make sure you record every step and detail thoroughly. Accurate documentation supports traceability and helps in audits or troubleshooting. When evaluating your results, always compare them against specified tolerances to confirm they meet quality standards. Lastly, training staff on proper technique cannot be overstated. Well-trained personnel are essential for maintaining consistency and reducing errors. Remember, applying these best practices not only improves the quality of our work, but also aligns with our overall goal of maintaining integrity and compliance in our processes. If you need any further support, please don't hesitate to reach out to us. We're here to help and ensure you have all the resources you need. Thank you so much for your time and attention today.